Okay, so getting ready for senior level software engineer interviews, right? I mean, it's a lot.
It really is. It can feel like you're trying to drink from a fire hose sometimes. So many topics, so much to review.
Right. Exactly. And, there's that pressure to really demonstrate
Mhm.
you're not just like a code monkey anymore. You've got to show that deep understanding.
Absolutely. That senior level thinking, the problem solving, the ability to make architectural choices.
Exactly. So what we want to do in this deep dive is zero in on a specific area that comes up all the time in these senior interviews, and that's string manipulation in Java.
Makes sense. It's fundamental, right? It's in practically every coding challenge in some way.
Totally. We're going to go right to the source, the Java String API, and break down the core concepts that you absolutely need to have nailed down. So think of this as your cheat sheet for getting that practical high-level understanding without getting bogged down in every little detail.
Perfect. And we'll focus on why these concepts are relevant for the kinds of problems you'll see in an interview setting.
Right. Not just what the methods are, but how they connect to real-world challenges.
Hmm.
So first things first, let's talk about one of the most fundamental principles of strings in Java: immutability.
Right. Immutability. Can you quickly remind us what that means in this context?
Yeah, so immutability basically means that once a string object is created in Java, its contents, the actual characters in it, can't be changed.
Okay, I see. So if strings can't be changed, how do we explain all those string methods that seem to modify them? Like if I have a string hello and I call to uppercase on it.
Right, you'd think it would just change that string to hello, right? But that's not actually what happens.
Okay, so what's going on under the hood?
Instead of modifying the original string, those methods actually return a new string object with the changes applied. So in your example, to uppercase would create a brand new string, hello, and leave the original hello string completely untouched.
Oh, interesting. So even though it looks like we're changing the original string, we're actually creating a new one.
Exactly. And this might seem like a subtle difference, but it has huge implications when you start thinking about things like memory management and thread safety, especially in large, complex applications.
Right, because if multiple threads are trying to modify the same string at the same time, you could run into all sorts of problems with data corruption.
Exactly. But because strings are immutable in Java, we avoid those headaches altogether. It also kind of pushes you towards a more functional style of programming, which can lead to more predictable and testable code, right?
Yeah, that's a great point. Okay, so we've got this concept of immutability down. What are some of those key methods in the string API that we'll probably use a lot?
All right, so let's break down the methods.
Hmm.
A good way to think about it is to group them by their function. So first, we have methods that let us check certain properties of a string.
Okay, like what?
So you've got startsWith and endsWith. Pretty self-explanatory, right? Use them to see if a string starts or ends with a specific sequence of characters.
Yeah, basic stuff. I use those all the time for like simple validation.
Sure, basic validation, but let's think a bit more strategically. Like, how might you use these in a larger application? Say, to make some high-level architectural decisions.
Yeah. Okay, so let's say you're building a web server. You could use startsWith to route requests based on the URL. So if a URL starts with epio, you know it's an API request, and you can send it to the right handler.
Right, so instead of just checking if a file name has the right extension, you're using it to guide the flow of an entire system.
And what about errors? Can you think of how these simple checks could prevent more serious issues?
Oh yeah, for sure. Imagine you're working with log data. You could use startsWith to quickly filter out logs from a specific source, like a particular server or component, early in the process.
Right, and that could save you tons of time debugging later on.
Totally. Okay, so what else do we have in terms of checking string properties?
Then there's contains. It checks if a specific sequence of characters is present anywhere within the string. It doesn't need an exact match with the whole string, just a part of it. So how would you use that differently than, say, just checking if two strings are equal?
Think about something like a search feature. You're not looking for an exact match, right? You just want to see if the search term appears anywhere in the text.
Ah, I get it. So it's about finding occurrences, not necessarily comparing entire strings.
Exactly. Okay, moving on. We also have methods for finding specific parts of a string, indexOf and lastIndexOf.
Oh, yeah, those are classics.
So what's the key difference between them? When would you specifically choose one over the other?
So indexOf gives you the position of the first occurrence of a substring within a string, counting from the start. LastIndexOf starts at the end and gives you the position of the last occurrence.
Okay. And can you give us a real-world example?
Sure. Let's say you have a file path like home user documents report.pdf. You want to extract just the file name, report.pdf. The most reliable way to do that is to use lastIndexOf to find the last slash, and then you can grab everything after it.
That's a great example. Now, those methods also have versions where you can specify a starting point for your search. What's the benefit of being able to do that?
Yeah, so those are indexOf and lastIndexOf with the from index parameter. And that can be super helpful when you need to find multiple occurrences of the same substring.
How so?
Imagine you're parsing a code file and you need to find all the places where a specific variable is used. You could use indexOf, but each time you find the variable, you'd update the from index to start your next search right after the last match. It helps you go through the string methodically.
Right, it's like you're stepping through the string. And there's something else about indexOf and lastIndexOf that's super important to remember in any code you write.
Oh, yeah. If the substring you're looking for isn't there, they both return -1.
Exactly. You've got to handle that case.
Yeah,
Otherwise, your code could crash or do something weird.
makes sense. Okay, so we've covered methods that check properties and find substrings. What about actually changing the content of strings?
Right, so remember that strings are immutable, so we
Mhm.
can't technically change them. But there are methods that let us create new strings based on the original, with some modifications.
Okay, that makes sense. What are some of those methods?
A common one is replace. It lets you replace all occurrences of a specific substring with another one.
Yeah, that's a pretty basic one. How would a senior engineer think about using replace in a more sophisticated way?
We'll think about data sanitization. If you're dealing with user input, you might use replace to remove potentially harmful characters or scripts before storing or displaying that data.
That's a good one. I've also used it for data transformations, like converting data from one format to another by replacing specific delimiters or markers.
Right, it can be a powerful tool for data manipulation, even if it seems simple.
For sure. What about to uppercase and to lowercase?
Yeah, those are also really common. And while their basic function is obvious, they become super important when you need to do case-insensitive comparisons.
Yeah. Right. Like if you're building a login system, you don't want capitalization to matter. You want username and username to be treated the same.
Exactly. Or if you're searching for something in a database, you'd probably convert everything to lowercase first to make sure you catch all the matches.
Okay, that makes sense. Any other important string modification methods?
Don't forget about strip.
Oh, yeah, trimming whitespace. That seems pretty basic.
It is, but it's also super easy to overlook, and it can cause subtle bugs if you're not careful.
How so?
Well, think about user input again. People might accidentally add extra spaces at the beginning or end of their input. If you're not trimming that white space before storing or processing the data, you could end up with all sorts of inconsistencies.
Huh, I see. So it's about ensuring data integrity.
Exactly. Okay, now let's get into something that can really differentiate a senior engineer. Understanding the difference between code points and code units.
Okay, this sounds interesting. What's that all about?
Well, it gets into how Java handles Unicode and represents characters internally. It can seem a bit technical, but it's important if you're building applications that need to work with a wide range of languages and characters.
All right, I'm all ears. Tell me more about code points and code units.
So every character in Unicode has a unique identifier called a code point. It's basically a number that represents that character.
Okay, so each character has its own code. Makes sense.
Right. Now in Java, the char data type, which is what we use to store individual characters, is 16 bits long.
I see. So each char can hold up to 16 bits of information.
Right. And back when Java was first created, Unicode was also 16-bit. So it all worked out nicely. Every character could fit in a single char.
But then Unicode expanded, right, to include more characters from different languages and rating systems.
Exactly. And it went beyond 16 bits. So now you have characters that need more than 16 bits to be represented.
Oh, that makes things more complicated. So how does Java deal with that if a char can only hold 16 bits?
That's where code units come in. A code unit is still 16 bits. But for characters that need more than 16 bits, Java uses two code units together. This pair of code units is called a surrogate pair.
So some characters are represented by a single code unit, which fits in a char, and others need two code units, a surrogate pair, to represent the full character.
Exactly. And here's the key. When you use methods like charret or length, you're working with code units, not necessarily full Unicode characters.
Ah, okay. That's a crucial distinction. I see how that could cause problems if you're not aware of it.
Right. For simple text in English, it might not matter. But if you're dealing with, say, Chinese characters or emojis, you can run into issues if you assume that every char is a complete character.
So how should senior engineers think about handling these cases where you need to work with full Unicode characters?
Java provides methods specifically for that. You've got code point add to get the full code point at a specific index, and code point count to get the total number of code points in a string.
So those methods let you work directly with the actual Unicode characters, not just the code units.
Precisely. And you can also use the code points method to get a stream of all the code points in a string.
Okay, so you have different tools for different levels of detail. And why is understanding all of this so important in a senior engineer interview?
It shows that you're not just memorizing methods, you actually understand the underlying mechanisms and how strings are represented in Java. It's about recognizing potential edge cases, especially with internationalization, which is a big deal in today's world.
Right. It's about being able to think beyond the basic level and build robust, globally aware applications.
Exactly. Okay, so we've covered a lot of ground with the classic string methods, but let's shift gears and talk about a newer feature in Java, text blocks.
Oh, yeah, I've heard about those. They're supposed to make working with multi-line strings a lot easier.
They really do. Before text blocks, if you had a string that spanned multiple lines, you had to use a bunch of end characters for new lines or concatenate strings together. It was messy and hard to read.
I've definitely been there. So how do text blocks work?
They're defined using triple quotes. You start with Alan, a new line, and then your multi-line string, and then another to close it.
So no more escaping new lines or messing around with concatenation.
Exactly. It makes code much cleaner, especially if you're working with like SQL queries or HTML fragments, which often span multiple lines.
That makes sense. Are there any special rules or quirks about how text blocks handle whitespace and line breaks?
Yeah, there are a few things to keep in mind. For example, the line break right after the opening isn't included in the string. And if you don't want a trailing new line at the end, you have to put the closing right at the end of the last line.
Okay, so some subtle formatting things to be aware of. What about quotation marks inside the text block? Do we still need to escape those?
That's a nice thing about text blocks. You generally don't need to escape single or double quotes inside them. The only time you need to escape a quote is if it's at the very end of the text block, or if you have 3 or more quotes in a row.
Got it. So it's a lot more intuitive for most cases.
Right. And Java also does some automatic cleanup with whitespace in text blocks.
Oh, really? How so?
It removes any trailing whitespace at the end of each line. And it converts all line endings to the standard new line character, so you don't have to worry about those pesky Windows-style ARN endings.
That's pretty handy. What about leaving whitespace?
It handles that intelligently too. It looks at all the lines in the text block and finds the longest common sequence of leading whitespace characters. And then it removes that prefix from the beginning of every line.
So it automatically indents the text block based on the least indented line.
Exactly. But you got to be careful. If your indentation is inconsistent with a mix of tabs and spaces, it might not remove as much leading whitespace as you expect.
Makes sense. So how does all of this connect back to senior level interviews?
Well, imagine you're asked to represent some complex data structure as a string, like a JSON object or a piece of YAML configuration. Using a text block would be a great way to do that cleanly and show that you're up to date with modern Java features.
Right. It would demonstrate good coding style and a willingness to use the right tool for the job.
Exactly. Okay, so we've covered a ton of ground in this deep dive. Let's recap the key takeaways for those senior level interviews.
All right. So first off, immutability of strings in Java. Remember that all those string methods create new strings instead of modifying the original.
Right, and make sure you have a solid grasp of those key methods. Starts with, ends with, contains, indexOf, lastIndexOf, replace, to uppercase to lowercase, strip. Understand when and why you'd use each one.
Don't forget the difference between code points and code units. That's crucial for building applications that can handle international characters correctly.
And know how to use those code point specific methods. Code point at, code point count, and code points.
And lastly, embrace text blocks. They make working with multi-line strings so much easier.
Exactly. So to wrap things up, here's something to think about. Imagine you're debugging a string manipulation issue in a really complex application. You're staring at the code, and it just doesn't make sense. How might that deep understanding of string encoding, of code points versus code units, help you crack the case? What assumptions might you have made if you were just focused on those basic string methods? It's that deeper understanding that makes all the difference.
It's what separates the senior engineers from the rest.
Exactly. And as always, keep exploring, keep learning. The Java API documentation is your friend. Thanks for joining us on this deep dive.